Welcome to the deep dive. Today we're plunging into, well, probably the most talked about technology in years, Generative Artificial Intelligence, GAI. You've definitely seen the stunning images, maybe played with the text generators, but our sources today promise to take us a bit deeper, beyond just the hype.
Yeah, there's a lot beneath the surface.
We've gathered research that really digs into GAI's, profound capabilities, but also where it fundamentally breaks down. And importantly, where experts think things need to go next for true reliability.
It really is a massive shift. I mean, think about it. GAI systems don't just crunch data. They generate new stuff. New text, images, code, you name it.
But how do they actually do that?
Well, the core mechanism is pretty incredible. They learn to spot and then reconstruct really complex patterns from just immense amounts of data, truly vast data sets.
Okay, and that sets up the big question for today, doesn't it? This core tension. How can these systems create things that seem so creative, sometimes honestly better than humans, yet still lack genuine understanding, real context? It feels a bit like watching a very, very skilled mimic.
That mimicry analogy, it's spot on. Fundamentally, GAI excels at learning and mirroring these intricate statistical regularities found in its training data.
Statistical regularity.
Right. That lets it produce outputs that seem plausible in context, text that reads well, an image that looks real. But for you, the listener, the question we have to keep asking is that the same as actually understanding? Is plausibility comprehension?
Right. So let's unpack that. Let's start with the highlights. Where are these systems really knocking it out of the park right now? What's the achievement reel look like?
Well, the fluency is just extraordinary, and mimicking creative processes, I mean. We're not talking about just filling in templates.
No.
We're seeing deep learning models create pretty coherent stories, generate fluent technical writing, and this is a big one, create genuinely novel images that capture complex styles and ideas.
And it's not just words and pictures, right?
Yeah.
Our sources point to big successes in areas needing complex strategy, things that really push computational limits.
Absolutely. Take highly structured strategical games. Chess, Go. Even something incredibly complex and fast-paced like StarCraft 2.
StarCraft 2, yeah. That's intense.
It is. And the AI often outperforms the best human players.
Yeah.
It doesn't just copy known strategies. It develops entirely new ones, new tactics.
Okay, but hold on. How does an AI develop a novel strategy? Is it actually thinking creatively, like outside the box, or is it something else?
It's more like leveraging sheer computational power and this sort of data-driven adaptation. In StarCraft 2, for example, human pros might ignore certain strategies because, decades of play suggest they're too risky or just don't work well.
Right, conventional wisdom.
Exactly. But the AI, having played millions of simulated games, might take one of those discarded approaches and execute it with such perfect timing and precision that it finds a path humans just missed. It reveals a hidden optimum.
So it explores the entire possibility space in a way humans just can't.
Precisely. And that looks like creativity. But here's the crucial point, the philosophical question, really. These strategies, however novel they seem, are still ultimately born from just exhaustive analysis of pre-existing patterns within the game's rules and all that data.
Ah, okay. So we really need to distinguish between simulation, mimicking an action perfectly, and genuine originality, understanding the why behind the action.
That's the heart of it. If we want AI working alongside us in critical areas, things tied to human values, unpredictable situations, we have to know if we're dealing with real intelligence or just the world's most sophisticated pattern matching machine.
It really sounds like these are systems that are masters of correlation, finding connections in data, but maybe not causation or true insight.
That's a good way to put it.
So despite that incredible fluency, that mimicry, the sources flag some deep problems, constraints that limit how reliable GAI can be in the real world. Let's pivot to those issues. What happens when these models go wrong, especially where the stakes are high?
Okay, yeah. The first, and probably the most talked about failure, is what we call hallucination.
Right, the jargon.
Yeah.
For listeners who aren't familiar, what does that actually mean? What does a hallucination look like?
It means the model spits out stuff that's just nonsensical or totally wrong for the context, or, and this is the dangerous part, a completely fabricated information presented as fact, often with utter confidence.
Oh.
This is where that lack of grounding really bites you. A GAI can write a perfectly structured, convincing paragraph citing, say, a specific legal precedent or a scientific study that simply does not exist. It just made it up.
So the output sounds right. It looks plausible, like something an expert would write.
Yeah.
But the core facts are invented because the model has no real mechanism to connect its words back to verifiable, real-world truth. It can't fact-check itself.
Exactly. It's just following the statistical pattern of what a reference looks like, but it can't check the underlying reality. And obviously, this raises huge reliability concerns. Imagine using that in medical diagnosis or legal research.
Yeah, the potential for harm is enormous. You need incredibly robust guardrails, built-in checks against reality.
Absolutely paramount.
Yeah.
Consistency, alignment with verifiable facts. It's non-negotiable in those fields.
Makes total sense.
Yeah.
If you can't trust the output, its usefulness plummets. Okay, what was the second major limitation the sources highlighted? Another reliability issue.
The second big one is misalignment. GAI often struggles to align its output with what the user actually intends, or with what's appropriate for the situation, or even with basic ethical constraints.
Can you give an example of that? How does misalignment actually show up?
Sure. Think about asking a GAI to summarize a complex scientific paper. You might implicitly want a simple summary, maybe for a layperson.
Right.
But if you don't explicitly say, summarize this for a 10-year-old,
Yeah.
the model might just give you back a slightly shorter, but still highly technical, jargon-filled version because that's the dominant pattern it learned for summarization.
So it misses the implicit context, the user's real need.
Yes. And more seriously, this misalignment means outputs can sometimes ignore safety rules or subtly reinforce biases that were present in its training data. It prioritizes fluent output over sticking to those context-specific guardrails.
And people have tried to fix this with instruction tuning. Right. Training the model specifically to follow instructions better. But it sounds like that's not a silver bullet either.
It helps, but it's often more like a bandage. It's fragile. Instruction tuning tends to work best only for the kinds of tasks it was heavily trained on. The minute you give it something truly novel or ambiguous a situation, it hasn't seen countless variations of that instruction following can just fall apart. It fails drastically sometimes.
So it's not really scalable for the messy, unpredictable real world where context and ethics are always shifting.
Exactly. That fragility really questions how well current GAI can handle complex real-world jobs where nuance matters constantly.
Okay, so we have models that can confidently lie, and models that don't always grasp what we actually want or need. What's the deeper underlying reason connecting these problems? What's the fundamental ceiling here?
That brings us to what some of the sources call the epistemological void. It's a really core concept.
Epistemological void. Sounds serious.
It kind of is. It explains why these limitations persist. Basically, despite being amazing at reproducing statistical patterns, GAI systems fundamentally lack the kind of intentional, context-sensitive interpretation needed for truly meaning-aware intelligence, the kind that's ethically responsible.
Okay, what does meaning-aware really entail here? Is it just common sense or something more?
Common sense is definitely part of it, but it's broader. It means a GAI can't truly reason about things it hasn't seen millions of times. For instance, they really struggle with affordance detection.
Affordance detection?
Yeah, that's like the very human ability to look at a chair and instantly know you can sit on it, stand on it, maybe use it to block a door. We understand physics, context, intent.
Right, the potential uses of an object.
Exactly. GAI struggles to grasp these basic physical properties, contextual possibilities, intentions. Unless they're explicitly spelled out or heavily represented in the data, it can't easily align itself with these fundamental parameters of reality.
So it's essentially trapped within its training data. It knows the statistical likelihood of the next word, but not the meaning or the why behind it.
Precisely. The epistemological void idea suggests that just making these models bigger, feeding them more data, isn't going to bridge that gap to genuine intelligence on its own. Improving instruction following helps a bit, but it's marginal because it doesn't fix the core problem, grounding those instructions in real-world meaning and contextually appropriate action.
Okay. So we've hit the ceiling of statistical mimicry. That's clear. The big question then is, what's next? If more data alone isn't the answer, what is the key to getting deeper, more reliable, context-sensitive AI? Where do the experts see the path forward?
Well, the consensus emerging seems pretty clear. These persistent problems, hallucination, fragile instructions, they point towards needing a real shift. A shift towards what are called neurosymbolic approaches.
Neurosymbolic. Okay, let's make sure we unpack that for everyone listening. Sounds like combining two different traditions in AI.
That's exactly it. You've got the neural part, that's the neural networks, the deep learning models like in current GAI. They're great at adaptive learning, pattern recognition, handling fuzzy data.
Okay.
Then you've got the symbolic part, That's more like traditional AI, classic computer science, structured logic, explicit rules, provable reasoning, reliable instruction following.
So you're trying to give the flexible neural nets a kind of logical scaffolding,
Yeah.
a rules engine to keep them on track.
That's a great way to think about it. You get the adaptability of the neural net, but combined with the precision and the guardrails of symbolic logic. This fusion marrying statistical learning with logical rigor seems essential if we want to push GAI towards truly dependable action and maybe genuine understanding.
So it helps ground the outputs, connect them back to some verifiable logic.
Exactly. It could help verify facts, follow complex rules consistently, not just guess the next most statistically likely word based on the patterns it's seen.
Interesting. Okay, so integrating logic is one path. The sources also mentioned some early stage research looking at cultivating kind of self-awareness in these systems. What does that involve?
Yeah, it's nascent work, but important. The idea is if GAI is going to operate more autonomously, it needs some way to know when it's going off the rails, when it's failing or producing nonsense.
Like internal quality control.
Sort of. Research is exploring ways for systems to develop basic forms of self-awareness by essentially monitoring their own performance against certain metrics or constraints.
That sounds like a step towards systems that could potentially correct their own mistakes, right?
It is. There are examples in areas like, say, abnormality detection in complex networks. Models are designed not just to generate outputs, but also to recognize when their own output deviates significantly from expected norms or real-world data.
How do they do that?
They're using some sophisticated methods, things like Bayesian inference, feedback loops, architectures where the system can try to infer the cause of an anomaly it detects in its own process and then adjust its strategy in real time without a human stepping in.
That sounds potentially very powerful.
Yeah.
But you said nascent research.
Yeah.
Constraints. This isn't like human consciousness, right?
Absolutely not. We have to be really clear here. These self-monitoring capabilities are currently very limited and highly task-specific. They totally lack the kind of reflective self-consciousness, subjective experience that we associate with human agency, human thought.
So it's more like a thermostat checking the temperature than deep introspection.
That's a fair analogy, yes.
Yeah.
It's measuring performance against a goal or a baseline, not reflecting on its own existence or purpose.
Okay. So the bigger philosophical goal then, looking way ahead, must be to somehow bridge this massive gap between what we have now simulated agency, where the AI just looks like it has goals, and intrinsic goal-directedness, the kind real living things have with genuine intent.
That really is the ultimate frontier. Future systems probably need to have fundamental feedback mechanisms built in from the ground up, mechanisms for constantly monitoring performance, modifying actions based on actual outcomes, and aligning what they do with shifting contextual demands.
Building in the capacity for self-correction and adaptation based on real results.
Exactly. By embedding those principles deep in the architecture, maybe AI can inch closer towards the kind of adaptive, intentional intelligence we see in biology, instead of just remaining incredibly sophisticated prediction machines.
So let's try and bring this all together for you, our listener. We've seen that generative AI is, at its core, a master pattern recognizer. Incredibly successful in structured places like Games Go, StarCraft 2, where the rules are fixed.
Massive success there.
But that very reliance on statistical mimicry leads to critical reliability problems when things get ambiguous or the stakes are high. Issues like hallucination, making things up, and serious misalignment with user needs or ethics.
And the path forward, dealing with that underlying epistemological void, seems to lie in integration. Bringing together structured reasoning with data-driven learning, maybe through neurosymbolic AI, and building towards systems that can monitor their own performance, aiming for goal-directedness beyond just simulation.
It's about building a foundation for actual meaning, not just surface-level fluency.
Well said.
Which brings us to our final provocative thought for you to chew on after this deep dive. We heard that even genuinely novel strategies in complex games like Go ultimately come from analyzing pre-existing patterns. So what specific kind of input, maybe sensory data, maybe real-world interaction, maybe something else entirely, would a GAI system need to truly exhibit creativity that goes beyond statistical mimicry? What would it take for genuine, meaning-aware originality to emerge?